Okay, so hey everyone, today I'll be doing the 4.3 IG math quiz. So first question one, a particle moves in a straight line, so the displacement s in meters from a fixed point O is after t seconds is given by s equals t cubed plus 3t squared plus 6t minus the particle at rest. Select all that apply. Okay, first of all, don't let this fool you. Don't let the select all that apply fool you, because as you can see, the answer is the particle is never at rest. So just ignore that. Now, the velocity here, they're talking about this at rest means that v is equal to 0 meter per second, right? You guys know this. This means that there's no motion, there's no speed, which means that this is our velocity. Now, the velocity is the derivative of the displacement with respect to time, okay, or ds by dt. So v is equal to derive this basically 3t squared plus 6t plus 6. Now, okay, normally I would go straight away by using the quadratic formula or factoring or whatever you guys want. However, I have this option. Whenever I see the particle is never at rest, the first thing I want to do, only when I see this option, by the way, if it's a written question, I'd also want to do this, but only when I see this option in a multiple choice, keep this in mind, multiple choice, not typing, multiple choice, computer part, I would always apply delta, which is b squared minus 4ac. Okay, always in general just check, because you'll see now why. So let's substitute in our values. So b squared, b is 6, so 6 squared is 36 minus 4ac, so 4 times a, which is 3 times 6. Okay, this is delta. So let me write, that's it. This is delta. Delta is equal to 36 minus 4 times 3 times 6 gives me negative 36. Okay, now you guys know that when delta is greater than 0, two real roots in our quadratic. Okay, when delta is less than 0, no real roots. And when delta is equal to 0, one real repeated root. Okay, now here delta is less than 0, so our condition is the second one. There is no real roots. Okay, so let me just erase this. Okay, we have no real roots, which means that whenever you solve this, right, we're gonna set this equal to 0. And when if you were to graph this, essentially what they're trying to say, let's say that here is v, here is the time, it will never pass the x-axis, which is the t, which means that the particle is never at rest, right? Which means that the velocity is never at 0. So the particle is never at rest. Because what it means, when we have delta to be negative, right? It could either be this, like this is our velocity, this is our time. Okay, it could either be this for our quadratic, or it could be this. Essentially, it never passes the x-axis, which means that the velocity is never ever 0, right? The velocity is always going to be positive, which means we're always moving. So we don't even have to solve, because even if you were to do it on a calculator, by the way, it would give you imaginary roots. So you'd have whatever number, something, let's call it the number bi, for example. I is an imaginary number, which means that there are no real roots. So this is wrong, this is wrong, this is wrong, this is wrong. This is the only correct answer. Okay, question 2. A particle is moving along the x-axis, so that any time t seconds, its position from origin is given in meters by x of t, 2t squared minus 8t minus 5. The average acceleration of this particle between t 3 seconds. Okay. They want the average acceleration. Now, we have the displacement, right? Let's keep it in terms of how they want it. So, velocity, is the derivative of the displacement, which is normally given by s, but here it's given by t. So actually, let me just rewrite it as dx over dt. Now, you need to know, it's not required in this question, but you need to know, it came in the book, it's in the book, and they might ask it, you never know. They did ask it in a later question. The average, the instantaneous acceleration, okay, or a, is the derivative of the velocity with respect to the time, right? So, but these are instantaneous. So what we're gonna do here, we're gonna ignore this part. We're gonna find the function of the velocity. So, vt equals to x prime of t. This is used to denote a derivative of a function. I don't know why I drew that line. There's no fraction. 4t, we're just deriving this. We're deriving the displacement. 4t plus 8. Okay? Now, this is the function of the velocity. So we're going to erase this part here. We're going to bring this closer. Okay. Now, the average acceleration equals to the velocity at the final time minus the velocity at the initial time over the final time minus the initial time. You know what from physics? A average or A bar, doesn't really matter, equals to delta V over delta T. You guys know this. Okay, anyway, now that we're here, we're gonna plug in our values. So at T3, this is the initial time, and this is the final time. We're gonna plug in our values into this function, and then we're gonna put them into the fraction. So first of all, I always like to start, this is preference, I always like to start by plugging in my time. Our final time is 5, our initial time is 3, so I just put in the times. Now I put in the values of the velocity. So v of 5 equals to 4 times 5 plus 8, this equals to 28, right? And v of 3 equals to 4 times 3 plus 8, this equals to 20, right? So this is going to be 28 minus 20 over 5 minus 3. So this is going to be 8 over 2, which equals to 4 meter per second squared. And this is our final answer. Okay, question 3. The average speed, okay, the traveler left home at 7:30. Anything given here, this is just we can see it from the graph, so I'm not gonna read it. The average speed from the time interval 8:30 to 9 is y kilometers an hour. What's the value of y? Okay, so first of all, a lot of you guys will put, since this is an hours minute, hours colon minute, and this is also hour colon minute, we need to change it to hours. Now, you guys should know how to change it to hours. You keep the hour, right? For example, when you use 8:30, you keep the hour, add a decimal point, then divide the minutes, which in this case is 30. 30 over divided by 60, which is equal to 0.5. So then you just add this number here. Anything after the decimal point, right, is what we're gonna add to the actual, the actual number. So 8.5. So 8:30 is 8.5 hours, right? Same thing for this one. 0 divided by 60 is gonna give me 0, so 9.0. So straight away now, 9.0 minus 8.5, we plugged in our time. They want the average speed. Remember that the average speed, S bar, is equal to distance over time. Okay, so our distance, we're gonna read it from the graph. At 9 o'clock, right? At 9 o'clock, it is, let's trace it here, 180. So 180 minus, at 8:30, it's 120. So this equals to 180 minus 120 over 9 minus 8.5. I don't know why I added the fraction line. This equals to 120 kilometers an hour. This is your final answer. Okay. A particle moves along the x-axis so that at time t seconds, the displacement from the origin is x meters, where x of t is equals 8t squared minus 5t plus 13. Its velocity when moving to at t 2 seconds. Okay, again, this is very simple. They want the velocity. They want instantaneous velocity. By the way, keep in mind also average velocity is v is, sorry, the x or the displacement, which is s or x, both are terms for displacement. T final minus x of t initial over t final minus t initial. However, they don't want this, right? They want instantaneous. This is average, right? So we're gonna ignore this, and we're gonna focus on the other formula, v instantaneous, or I'll write v instant, whatever, v-i-n-s. Why does it keep doing that? VINST equals 2 d, here in this case it's x of t, so dx by dt. Or another way to write a derivative notation, you know that if you have a function f of x, its derivative is equal to f prime of x, right? This is the derivative. Okay, so at t 2 seconds, so the average, the instantaneous velocity, so I'm gonna write v instantaneous velocity equals to x prime of t, which equals to, then you just derive this, 16t minus 5, right? This is the derivative. Okay, now we're gonna plug in 2, so v t equals to 16t minus 5, plug in 2 at this, so v of 2 equals to 16 times 2 minus 5. This is gonna equal 32 minus 5, which is equal to 27 meters per second. And this is our final answer. Okay, question 15. A particle is moving along the x-axis so that at time t seconds, its displacement from the origin is x meters, where x of t is equal to 1 over 3t cubed plus 4t minus 4, the average acceleration. Okay, average acceleration. This is the formula I told you guys about. First of all, we're going to write it delta v over delta t, if you want, in the terms of physics that we took last year. Or if you're not in the transition, the physics you took this year. So it's going to be, but in terms of the math, it's VTF minus VTI over TF minus TI. Okay, so let's first of all, and obviously let's find V of t. So Vt equals 2, or V in general is the derivative of x of t, so x prime of t equals 2. This is a multiplicative constant, keep this in mind, by the way, 1 over 3t cubed. I'm looking at this, by the way. 1 over 3t cubed. You keep this, and then you derive the variable. So let's derive this. X prime of t equals to 1 over 3 times 3t squared. Again, you keep the 1 over 3 plus 4t, the constant always differentiates to 0, so ignore this. 4t differentiates to 4. So x prime of t is actually, simplifying to 1 over 3, and the 3 cancel out. T cubed, or t squared, sorry. T cubed, t squared. Why do I keep saying t cubed? T cubed. T squared plus 4. So t squared plus 4. Okay. Now, what this is essentially, we have this. Now we're going to plug in the values during the first 2 seconds, which means that t final is equal to 2 seconds, and t initial, because it's during the first 2 seconds, is 0 seconds, right? Because they want it only during the first 2 seconds. So we're going to plug these into our velocities, and obviously, first of all, we're going to put them into our time, 2 minus 0. Okay, let's find v of 2. We know that v of t, which is here, is equal to 2 squared plus 4. So 2 squared plus 4 gives me 4 plus 4, which is 8 meters per second. 8. V of 0 equals to 0 squared plus 4, which is equal to 4 meters per second. Right, so it's going to be 8 minus 4 over 2 minus 0. So A is equal to 4 over 2, which is equal to 2 meter per second squared. And this is our final answer. Okay, so question 6. A particle moves in a straight line so that the displacement s in meters from a fixed point O after t seconds is given by s equals to t cubed minus 5t squared plus 20t plus 1, where t is greater than or equal to 0. So, right now, what we're going to do. The distance the travel. Okay, so we're going to find the displacement at the third second. So s of 3, since they want it during the third second. And subtract it, or subtracted by the displacement of the second, right? Because it's during the third second and it's the distance. So s of 3 equals to 3 cubed minus 5 times 3 squared plus 20 times 3 plus 1. S of 3 equals to 3 cubed minus 5 times 3 squared plus 20 times 3 plus 1 gives me 43. 43 meters. Okay, now we have this. I'm going to erase all of this. S of 2 equals to 2 cubed minus 5 times 2 squared plus 20 times 2 plus 1. So S of 2 equals 2. So 2 cubed minus 5 times 2 squared plus 20 times 2 plus 1, which is 29 meters. Okay, so I'm going to erase this now. Now we're going to subtract S of 3 minus S of 2, which is 43 minus 29, which equals to 14. 14 meters is our final answer. Okay, question 7. A particle moves in a straight line such that same given as the other question, the time when the acceleration is 40 meters per second. So notice that this is instantaneous, right? Because they're asking for the specific time at a specific acceleration. So we're going to derive twice essentially. So v equals to ds by dt. V is equal to 3t squared plus, or sorry, not plus, minus 10t plus 20. Okay, so now a is equal to the second derivatives, or dv by dt. So a is equal to 60 minus 10. Okay, so we want the time t, and we have given the acceleration, which is a. So 14, since our acceleration is 14, equals to 60 minus 10. Right? I just substituted 14 for a. Take 10 to the other side, becomes positive. 60 equals to 24. T is equal to 4 seconds. And this is our final answer. Okay. Question 18, or question 8, sorry. The average speed of the train between 9:30 and 11:30 is blank kilometers an hour. So average speed is equal to distance over time. Let me straight away plug it in. So 9.5 and 11.5. 11.5 minus 9.5. Okay, now look at the graph. 11:30, 300 minus 930, 150 equals 2. 300 minus 150 over 11.5 minus 9.5, 75 kilometers an hour. This is my final answer. Okay, so that was part A. Part B. This is equal to, this is 7.0, this is 9.5, so straight away 9.5 minus 7. Okay, now 9.5 or 9 hours and 30 minutes, we said it was 150. And at 7, it was 0. So 150 minus 0 over 9.5 minus 7. So 150 minus 0 over 9.5 minus 7, which gives me 60 kilometers an hour. And this is my final answer. Okay. Question 9, which is the last question. A train started from rest at 7 o'clock. The train accelerated. Whatever I can find here, I can find on the graph. Okay. This is the part of the sentence that I'm actually concerned about. The distance traveled during the entire hour is 63 kilometers an hour. And you know that the distance is the area under the graph. Okay. So they want the maximum speed. You can see that our maximum speed, our highest speed is v, right? And to find v, we're going to use this distance. Since you see that this shape is a trapezoid, right? It's a very obvious trapezoid. The area of the trapezoid is the height. Why does it keep doing that? The height times the first base plus the second base over 2. Okay? Now we have this. Our height, if you notice, is v, right? Because look, our height, which is our maximum speed, is v. So v, b1 plus b2 over 2. This is straight away. And we know that the distance is the area. So d equals to a. So this is actually 63 equals to all of this. Now, let's find our b1 and b2. Remember, kilometers an hour. So this is an hour colon minute. So what we're going to do, we're going to get our time in terms of hours only. So 8 hours minus 7 hours is 1 hour. So we're going to keep this. Okay. 750 minus 705 is 45 minutes. Right? So what we're going to do is change this to hours. 45 over 60. which is 45 divided by 60, which should be 0.75. Yeah, 0.75 hours. This is 0.7h. Nice one. 0.75 hours. Okay. So this means that what we're gonna do, our first base, so 63. Let me erase everything. 63 is equal to V times 1 plus 0.75. Because remember, we're keeping it in hours. Our base is time. Time in hour, code in minutes. They want it in hours. So we're changing it only to pure hours. And I showed the calculations over 2. Okay, do this on a calculator. So you're gonna get 1.75 over 2, which is 7 over 8, which is 0.875. So 63 equals to 0.875 V. So V is equal to 63 over 0.875, which gives me 63 over answer to be 72 kilometers an hour. Okay. So this is part A done. Now, we're going to change V here to be 72. The average acceleration for the first 5 minutes. So, first 5 minutes, which means it's from 0 hours and 5 minutes, or 0 hours and 0 minutes, to 0 hours and 5 minutes. So, this is a difference of 5 minutes in time, right? So, 5 over 60, which equals 2. If it's like a very weird number, we're gonna keep it as 5 over 60. Okay, since it's a repeating decimal, we're just gonna write this in our denominator. 5 over 60 hours. They want it again, kilometers an hour squared. Okay, now 72 kilometers an hour at 5 minutes, so it's gonna be 72. Because remember, it's they want average acceleration, so Vt final minus Vt initial over T final minus T initial. We found T final minus T initial, which is what we substituted. This is T final, velocity of the final time. The velocity of the initial time, which is at first 5 minutes, 7 o'clock, is 0. Okay, now do this on a calculator. A equals to 72 over 5 over 60, 864 kilometers an hour squared. And this is our final answer. And this is the end of the quiz. Yalla, good luck, guys.